Okay. Now, remember, first of all, you got to recognize that this is what kind of function? No, that's not quadratic. You even see absolute value bars, so that's an absolute value equation or function. So what does a graph look like? Like V. A quadratic function, the graph is a parabola. It looks like that U. Now, the other thing that you got to then ask yourself is this going to involve a vertical shift or a horizontal shift? Where's the number located? See, that's something you got to work on. We spent quite a few minutes talking about this last class period. So you have your parent function. What's your parent function? What's the parent function? Absolute value of x. So is that 5 on the outside absolute value of x, or is it on the inside of the absolute value bar? Inside. If it's inside, what do we say? What kind of shifting is it? Horizontal. Okay. So it's horizontal. Then you got to remember, well, that's where I got to take the opposite of what I see. So where's the vertex going to be when x is what? -5. When x is -5, if it's horizontal, you take the opposite of what you would see there. So instead of that +5, it should be -5 is where the vertex will be. So in the t-table, you'll have x -5, and in your mind, you'll say, well, that's going to give me my vertex. All right, and then after that, then you would pick 3 points to the left and 3 points to the right. Remember that? Mm-hmm. And then you would pick increments of 1, though, because if you do too many, it won't be within that grid. So some of you already know, though, that your vertex is -5 what? 0. If you did not know that my y-coordinate is 0, then in place of x, what do you plug in? -5. So I get y equals absolute value of -5 plus 5. What's the absolute value of -5? First of all, what is -5 plus 5? And what's the absolute value of 0? 0. All right. So then I start plotting that point. So -5, 0. Right here. And then once I locate it, then I know that I'm gonna choose what 3 x coordinates to the right. -4, -3, -2. So -4, -3, -2. And then I'm going to choose which x coordinates to the left. Okay. And then it's just a matter of you finding out what that y value is. So when x is -4, I get y equals the absolute value of -4 plus 5. What's -4 plus 5? What's the absolute value of 1? 1. So then I plot the point -4, 1. -4, 1's here. And then using the idea of symmetry, we talked about symmetry as well. So this graph is symmetric around that imaginary line that you see here, that vertical line going through the vertex. So using the idea of symmetry, you now know that when x is -6, then what should my y value be? 1 as well. Okay, even if you didn't know that, hopefully you did, but even if you did not, I'm going to go to -6 just to show you. When x is -6, I get y equals the absolute value of -6 plus 5. What's -6 plus 5? And what's the absolute value of -1? 1. So I get 1 also, using the idea of symmetry. -6, 1. All right, let's go to -3. When x is -3, I get y equals the absolute value of -3 plus 5. What's -3 plus 5? What's the absolute value of 2? 2. So I'll plot the point -3, 2. Once you know that, then you know the one over here. -7 what? 2. You see the idea of symmetry? All right, so -7, you say y equal the absolute value of -7 plus 5. What's -7 plus 5? Absolute value -2? 2. When x is -2, I get y equals the absolute value of negative 2 plus 5. What's negative 2 plus 5? Positive 3. Absolute value of 3? 3. So I get negative 2, 3, which is here. Once I know that, then I know what the y value is when x is negative 8. What is it? 3. So when x is negative 8, I get y equals absolute value of negative 8 plus 5. What's negative 8 plus 5?
Negative 3.
And what's absolute value of negative 3? Positive 3. And then now all you do is just draw your rays. Make sure you draw the arrows. Some of you are not drawing your arrows. Some of you are drawing segments. On the worksheet you turned in, a line is not a segment. A line is a line with 2 arrows. So make sure you don't forget that. And also what some of you are forgetting to do is you're plotting your points but forgetting to draw the line. And there's more than one person that did that. Okay, so there's the graph of y equals absolute value of x plus 5. Okay? Now, when we do my math lab, you'll notice that some of the graphs are pointing up, and some of them are pointing what? Down. So let's talk about, well, what makes it point down? All right. Okay, so let's look at this. Now, you can actually do my math lab without knowing what makes it point down, because there are no problems in my math lab for this section, that looks like this. G of x equal negative absolute value of x. So there's nothing where there's a negative out in front. But that negative out in front, see that negative right here, out in front of that parent function? Remember, the parent function is absolute value of x. The negative out in front makes all these y values right here what kind of numbers? What kind of numbers? Negative. And where are your y coordinates negative? Above the x-axis or below? Below. So that's where it's going down like that. So use the t-table. When x is 0, what's my y value? 0. Because the absolute value of 0 is what? 0. And the opposite of 0 is still what? 0. When x is, and remember when we did this, we used 0, 1, negative 1, 2, negative 2. Remember that? And 3, negative 3. When x is 1, I get y equals the opposite of the absolute value of 1. What's the absolute value of 1? And so this becomes a negative 1. When x is negative 1, I got y equals negative absolute value of negative 1. What's the absolute value of negative 1? 1. So this becomes a what? Negative 1. Okay? Don't forget to remember this is just bring the negative down. The absolute value of negative 1 is a positive 1, but this becomes still a what? Negative 1. When x is 2, I got y equals the opposite, or negative, absolute value of 2. What's the absolute value of 2?
2.
So it becomes a negative 2. When x is negative 2, well, what's the y value, though? No, not 2. Negative 2. The absolute value of negative 2 is 2, so it becomes a what? Negative 2. You agree? When x is 3, I got y equals negative absolute value of 3. What's the absolute value of 3? So it becomes a negative 3. When x is negative 3, I get y equals negative absolute value of negative 3. What's the absolute value of negative 3? So it becomes a negative 3. Now remember, when you're doing it, if you're doing the absolute value correctly, you better look, when you connect your points, they better be the shape of a V. So if it's off, you did something wrong. Okay? if it doesn't look like a V, one of your points is incorrect. So you got to go back and figure out what it is. Same thing for a parabola. It should be the shape of that U, that parabola. All right, so when I plot those points, I'm going to go ahead and to save some paper, I'm going to go ahead and put it on this one. So I get 0, 0, which is here, right? I get 1, 1, which is here. Oops, I did not mean 1. What did I mean to put here? Negative 1, right? Negative 1, because that was right here, right? Okay, so negative 1. So 1, negative 1's here. Negative 1 is here. The idea of symmetry still. 2, negative 2 is here. See how it's pointing down? Negative 2, negative 2. 3, negative 3. And negative 3, negative 3. And then it looks like this. All right, so this right here is y equals negative absolute value of x. Okay? So again, what makes it point down is that negative that's on the outside. All right, so if you had let's say this, again, in my math lab, your functions, that if you noticed when you did the problems, there were not any that had a negative out in front, but there were some in the multiple choice. There were some graphs that did point down. The only way you can get them to point down is if there's a negative out in front of the parent function. So, for example, for the quadratic, it would look like this. That's what it would look like. So that negative 1 there, would my graph be pointing up or down? It would be pointing up. The parabola would be pointing up. Since there's a negative out in front, my parabola would be pointing down. You learn more about that next semester when you graph quadratic functions. So quadratic next semester, you're going to, and when you solve quadratic functions using graphs next semester, you're going to see more of the pointing down graphs. Okay, so using a t-table, 0, 1, negative 1, 2, negative 2, 3, negative 3. So when x is 0, I get y equals the opposite of 0 squared. So the only thing that's being squared is that 0, right? Now what's 0 squared though? 0. And what's the opposite of 0? 0. So I have the origin, so I plot the point of the origin. That's here. When x is 1, I get y equals the opposite of 1 squared. 1's the only thing being squared, so what's 1 squared? 1. So this becomes a negative 1. Okay? So I plot the point 1, negative 1, which is here. When x is negative 1, I got y equals the opposite of negative 1 squared. So again, x is negative 1, so I'm putting negative 1 in parentheses. Now, remember, you do the exponent. What's negative 1 squared? 1, so this becomes a what? Negative 1. So 1, negative 1. I'm sorry, negative 1 is here. So again, using the idea of symmetry, remember it's a parabola, not a V, so don't all of a sudden start drawing rays. These are not rays, these are curves. When x is 2, I get y equals negative 2 squared, like this. What's 2 squared? So this becomes a negative 4. So 2 negative 4 is here. When x is negative 2, I get y equals the opposite of negative 2 squared, because x is negative 2, x is being squared. So what's negative 2 squared? Right here.
4.
So this becomes a negative 4. So again, if you're doing this correctly, it should be symmetric. You should see some symmetry. So negative 2, negative 4 is right here. And then when x is 3, I get y equals the opposite of 3 squared. What's 3 squared? So it becomes a negative 9. So 3 negative 9 is right here. And when x is negative 3, I get the opposite of negative 3 squared. What's negative 3 squared?
9.
So it becomes a negative 9. All right, and you draw your curve. Make it look like a parabola, though. Okay. In the next semester, you do more with this. You can learn about axes of symmetry. You'll find x-intercepts next semester with these quadratic functions. So you do a lot more with this next semester. A whole chapter on graphing quadratic functions. Okay. All right. So you should be able to do my math lab in that section. All right. Now, you remember we were talking about functions. What's the definition of function? For each x coordinate, there has to be exactly one y coordinate. Okay? And so, remember we're given a set of ordered pairs. Now, in that last class reduces the class we were before this. So let's say you had the ordered pairs 5, 2, negative 6, 1, 0, 0, 8, 2, negative 1, 5. All right, now, we also talked about the word finite and infinite. So when I drew this graph right here, how many, now these are all, everything we draw is a relation. Remember, relation is a set of ordered pairs. So all these are what here? Ordered pairs. How many ordered pairs are on this relation? An infinite number. Okay, that's going to be important in a little while. How many ordered pairs are in this relation? Yeah, but infinite versus what? Finite. So there's a finite number. Finite meaning I can count. I can count how many there are. There are how many there? 5. So this is a finite set. This is a what? Infinite set. Okay. So this finite set right here is this relation a function? So we did something like that 2 class periods ago.
Yes.
It is?
Mm-hmm.
Okay, so you're telling me that for each x coordinate there's exactly one y coordinate? Now remember when we did this? Okay, so last class we talked about the idea of a mapping, right? So sometimes a mapping will help you. So remember that little mapping that looks like this, where this is your x and this is your y. And my first point has what x coordinate? 5. It gets mapped to what? 2. So far, when x is 5, there's only one y coordinate. So we're good so far. My next x coordinate is negative 6. It gets mapped to what? 1. So far I'm good. When x is negative 6, it looks like I only have one y value, and it is 1. When x is 0, I get what y coordinate? 0. So far I'm good as well, because when x is 0, there's only one y value. It is what? 0. When x is 8, now remember, only use the numbers once, so don't write them twice if they occur more than once. When x is 8, I get what y value? 2. And this is what confuses people. That's okay for it to look like that. Because when x is 8, there's only one y value. It is what? 2. So it's okay for multiple x coordinates to have the same y value. It still satisfies the definition of function at this point. When x, for each of these x coordinates, there's only one arrow pointing from it. When x is -1, there's only one y value. It is what? 5. So is this a function? Yes, this is a function. Now leave some space here because we'll come back and talk about something else in a little while. Leave a little bit of space. So then, if I have this set of ordered pairs, let's say I had 2, -5, 1, 6, 0, 3, 2, 8.
It's not a function.
Why not?
Because of 2, you have 2 2s and the x.
So when x is 2, there's more than one y value. So if you use the idea of a mapping again, you'll see in terms of the arrows what transforms. So when x is 2, what's my y value? So far I'm good. At this point, I'm good so far. I only see one arrow coming from that 2. When x is 1, what's my y value? I'm good so far. When x is 0, what's my y value? I'm good so far. Now remember, I only list it once. So 2 occurs again, so only use the 2 that's already there, okay? When x is 2, what's my y value?
8.
So I got to put the 8 here. But notice how many arrows are coming from this 2? 2, more than 1 though. So when x is 2, I have more than one y value. I have how many y values? 2. So that's not a function. Not a function since when x is 2, when x equals 2, there are 2 y values. There can only be how many y values? 1. Right. Okay, now the other thing you got to know, besides given a finite set, whether it's a function or not, you have to determine the domain and range. So let's talk about what a domain is. The domain is a set of x coordinates. Domain is a set of x coordinates. Your range is a set of y coordinates. So the range is a set of y coordinates. All right, now there are in a little while you're going to find the domain and range of two things. A set of ordered pairs like this and an infinite set like this. For the set of ordered pairs like this, is this a finite or infinite set? Finite. If it's a finite set, here's how you're going to write your domain. You say domain equals or D equals, and you're going to use set notation. So notice when I label the set, I use a brace. So use a brace. Don't use parentheses for your set. It's a brace. So you can say domain equals open brace like this. And then all you do is list your x coordinates. Now remember, if the x coordinate occurs more than once, list it once. Don't list it more than once. So what are your x coordinates here? 5, -6, 0, 8, -1. It does not need to be in order, in numerical order. Just list them. So you see how to list it if it's a finite set? Right? So you're just listing your coordinates, your x coordinates. Now remember though, If any of them occurred more than once, only list it once. So your range, you can say R equals a set open brace. What's your y coordinates? 2, 1, 0. 2 already have.
Oh, yeah, sorry.
2 already have. And then what? 5. So that's your range. So your domain is a set of x coordinates. Your range is a set of y coordinates. Okay? But remember, and some of you are going to forget this, you're going to list 2 twice there. It should only be listed how many times? Once. In the next example, what's your domain?
2, 1, 0.
That's it, right? Okay, so close. So there's only 3 elements. There's only 3 elements in that domain: 2, 1, and 0. Because 2 is already listed, so don't list it again. What's the range?
5, 6, 3, 8.
Yeah. Okay. So that's your domain. Mind your range and domain. Okay. All right. Now, let's talk about an infinite set. Okay, now you got to listen carefully to this. So to do that, when I'm going to pass out something that looks like this. Notice, see, these are infinite sets, right? These are what kind of sets? What kind of relation? A finite set. This is going to be in this relation has an infinite set of ordered pairs. All right, so let me get that out. If it's a finite set, you're just going to list the elements. For an infinite set, you can use interval notation. So listen carefully as we do this. Okay, so look at the first one. That's the line. And whether it went down, well, whether it went down like this or went up, it doesn't matter for lines. Well, I want you to notice, though, now remember this arrow means it keeps on going down like this, right? Keeps on going down. So you gotta in your mind imagine it going all the way to infinity down this way. And the same thing here. Now, when I look at this point right here, just imagine this one. Look at this point right here. What's that y value? 8. When I look at this point right here, what's that y value? 9, and so on. So tell me something about these y values right here. The y values are increasing. All right. Now I said 8, I said 9, but do you see that this point right here could be 8.23876? It could, and this right here could be 10.749. The next one could be 7.49784. So you see where you get all these real numbers? The idea of infinity in the infinite set. Now, as you determine domain and range, here's what you need to be doing. For domain, remember domain is a set of x coordinates. What axis involves the x-axis? Horizontal line or the vertical one?
Horizontal.
The horizontal axis, right? Okay, so when you do the domain, and it helps if you kind of use some manipulative or something. But when you do domain, you go along the x-axis. Now remember, the x-axis goes this way, right? Or in this way. When you do this way, it's pointing towards what idea? Negative what? Infinity. Negative infinity. And this is pointing towards what? Positive infinity. Down here, that's pointing towards what? And up here, it's what? Positive infinity. Okay, keep those infinities in mind. Okay, now you see this arrow right here, this line, this arrow means it keeps going down. So as I go, now remember going along the x-axis, just like this. You see this? Along the x-axis. Now, although I'm starting here, it actually, you can't visualize this, but it's actually, this ruler is actually starting where? Negative infinity, because I'm getting all these negative numbers down here, right? Okay, so I'm going from negative infinity. Am I still touching the graph as I go along the x-axis like this? In other words, do I get a point? Do I get an x-coordinate here? Is this an x-coordinate? Is this an x-coordinate? X-coordinate, 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 and so on, right? So as I go along the x-axis, I'm getting some x-coordinates. So I'm going from negative infinity to what? Positive infinity. That's your domain. From negative infinity to positive infinity. So for this one, the domain would be, now remember that's an interval, so you can just say this, interval notation. Remember last semester you talked about interval notation in inequalities? Same idea. Negative infinity, positive infinity. Now remember last semester when you did infinity, negative infinity with inequalities, those are always parentheses. Okay. All right, now we're going to do the range in a little while, but let's talk about the domain with this one. See how these had arrows? Do you see any arrows here? No. Okay, so listen carefully. So remember, the domain, you start along the x-axis. When I go along the x-axis right here, let's say I'm here, do I get a point on the graph anywhere? No. I start touching the graph when I get to this x-coordinate. See it? What is that x-coordinate, though? -3. Okay. And I keep going, and I get all these x-coordinates, right? All the x-coordinates. And the largest x-coordinate I get is what? 7. So my domain will start when x is what? -3, and stop when x is what? 7. So here's how that's going to look. It will be a bracket. Because when x is -3, do I get a point on the graph? Yes. So it'll be a bracket, -3, all the way to bracket what? 7. Because when x is 7, this point is on the graph. So your domain, you go along the x-axis, and you determine what is the smallest x value and what is the largest x value. Okay? Remember, domain instead of x coordinates. What's the smallest x value on that graph? Well, that's here. And what's the, you see, all these other x values are getting bigger and bigger, right? These x coordinates, they're getting bigger and bigger, and then they're getting up to what? 7. Now let's talk about range with the circle. The range is your set of y coordinates. For that one, you go along the y-axis, but start at the bottom. So whenever you write an interval, you go from smallest to largest. So when I did the x-axis, I went from the left side to the what? Right side. When I do the y-axis, I'm going to go from bottom up. So tell me where I'll start touching the graph for my y coordinates. Right here, right? What is that y coordinate, though? -4. See, y is -4. See it? So the range will be bracket -4, comma, all the way, and what's the largest y value? 6. Okay, so that's your domain, and that's your range. So that's interval notation. All right, now let's go back to the line that had the arrows, and let's talk about the range. So again, you're going from you're using the y-axis, which is going to start at the bottom up. So now think of this as negative infinity. When I'm at, let's say, -1 million, do I get a point on the graph? Yes. -1 million, get a point on the graph. -2 million, and so on, right? So this is actually from negative what? Infinity all the way to, do I stop anywhere? No, I'm not stopping because their arrow keeps on going, right? To what? Positive infinity. So with the line, I just want you to know this, for a line though, as you do this, notice that if the line rises or falls, the domain range is going to be negative infinity to what? Positive infinity. For lines that rises or lines that falls, That's always going to be your domain and range for both of them. Negative infinity to positive infinity. All right, so let's look at number 3. Let's see what number 3 is. Let's skip that for a moment. Let's skip 3 and 4. All right, let's do 5. Let's skip 3 and 4 for right now. Okay, let's do 5. Now, those are your quadratic functions. See those? Those are not lines. Those are quadratic functions. All right, the easier one for you to understand would probably be the range for right now. So let's talk about the range. When doing the range, you go along the what? Y-axis. So I start touching the graph when I get to what y-coordinate? -7. Now notice these arrows keep going up. So tell me where to stop my ruler. You don't. You're going all the way to what? Positive infinity. So you start at -7 with a bracket to positive infinity. Now remember, infinity and negative infinity, you're always going to use what? Parentheses. So that's how it looks. So -7 bracket all the way to infinity. Now, let's talk about let's do the range with the bottom one. Now this time the arrows are pointing down. Okay. So when I did number 5, I went all the way to negative infinity, way down here, and I went up until I started touching the graph. At this point, I have not touched the graph at all. I start touching the graph when my y-coordinate is what? -7. When I do number 6, when I go way down here, am I touching the graph at all? Yes, because remember, this is what's happening. Just you got to imagine this going down like this. So what idea am I at right here? -50. So I keep going up and up and up, and tell me where my largest y value occurs. At 6. At 6. It doesn't occur any further than that, right? It's at 6. So my range here will be parentheses, -infinity to what? 6 with a bracket. That's how it looks. Yes?
Would we be able to write bracket 6 negative infinity?
No, because no, when doing domain and range, you always go from smallest to largest.
Okay. Thank you.
So the negative numbers are smaller than the positive numbers. So it's -infinity to 6, not the other way around. Okay, let's talk about domain this time. Domain, you go along which axis? The x-axis. Now, I want you to notice, although you kind of see, and the graph's not drawn very well, although it kind of looks like the graph is going straight up, it's not. It's actually, if I had drawn this a little bit better, it's actually doing this. You see it? And it's actually doing this. So my question to you is this: when x, remember for the domain, you start on the x-axis, right? So when let's say I'm at -1000, when x is -1000, do I get a y value on that graph? Yes. You got to imagine it. It's hard to do, but you got to imagine that this thing keeps going like this. Okay? Same thing here. So tell me where do you think my smallest x coordinate is? -infinity. So when x is -1 billion, I get a y value. It's way, way up there. You can't see it because of this grid, the way it is, but it's way up there. So you go from -infinity all the way to what? Yeah, I don't stop anywhere, right? I keep on going because this arrow keeps on going up like this. So my domain is -infinity to what? Positive infinity. What about number 6? What do you think domain is? Don't let the graph confuse you. It actually, I didn't draw it well, but it actually does this. Okay? Same thing. When I go along the, we're talking about domain. So when I go along the x-axis, when x is -100, I get a y value. It's way down here. You see it? But think of this as negative infinity, though. If this is negative infinity right here, do I get a y value? Yeah, is this ruler going to, at some point, touch this graph? Yeah. So I'm going from negative infinity all the way to what? Positive infinity. Okay? All right. Number 7 and 8 are the absolute value ones. The range is the easiest to deal with. What do you think the range is over here? Number 7. Smallest y value, largest y value?
4 to infinity.
Not 4 to infinity. We're talking about number 7. The range, guys.
Negative infinity to 2.
Okay, now listen. Here's what you do, okay? With the range, range is a set of what? Y coordinates. So I want you to take something like a ruler or your ID or something, and I want you to go along the y-axis like this. And I want you to tell me when I start touching the graph, right here, what is that y value? 2. So those are that give me different answers. I need for you to kind of use something like this, a manipulative or something. Okay? The y value is 2. So 2 to what? Infinity. Okay? 2 to infinity. Some of you are saying 4. 4 is your x-coordinate. But remember, the range is not a set of x-coordinates. The range is a what? Set of y-coordinates.
But wouldn't the left arrow be going to infinity?
Yeah, but you're going down, up.
Yeah, but you're looking for the range. So the range is a set of y-coordinates. Do you agree that this is my smallest point right here, my lowest point? What's that y value? 2. What's this y value? It's bigger than 2, right? It's going all the way to what? Infinity. So your range is 2 to infinity. What's the domain?
4.
Someone said 4. Okay, you're not listening very well from what we've been doing, girl. So this thing keeps going, right?
Yeah.
Keeps going. So for the domain, you're going along which axis? Okay. So think about negative infinity. If I'm at negative infinity, is this ruler at some point touching the graph?
Yes.
Yes, because this thing keeps going like this. So I'm going from negative infinity all the way to positive infinity. Now look at number 8. The range, you're going along your y-axis. So I need for you to do the ruler going like this. For the domain, your ruler is going to go vertical like this and go along the x-axis. Okay? So for the range here, notice the arrows are pointing down. So here, you're going from negative infinity because these y values are getting smaller and smaller. So you're going from negative infinity. And what is the largest y value I get to? Negative 2. With a bracket, though, for negative 2. So you need to use something like a ruler or some kind of straight edge. What is the domain? Negative infinity to positive infinity. Because if this right here is the idea of negative infinity, I am getting a point of the graph. See that? So I get an x value here, I get an x value here, I get an x value here, and so on. And I keep getting all these x values, right? So it's from negative infinity to what? Positive infinity. Okay. Now, when the ones we just did, those relations were a set of finite or infinite points. Infinite. Number 9 Oh, and I forgot to answer the other part of the question. The other part of the question was for you to determine whether it was a function or not. So let's go back and answer this. Is this a function? Yes, because it passes the what? Vertical line test. So it's a function. It passes the vertical line test. Is this a function? Yes, function. Is number 6 a function? Yes. Is number 5 a function? Yes. Okay, I remember we skipped 2. Let's go to number 2. We skipped 2 problems. That was 3 and 4. We'll come back to it. Is number 2 a function? No, it's not a function. Because it fails the vertical line test. In fact, you can see that when x is 2, see this right here, when x is 2, how many y values do I get? 2, 6, and -4. All right, you can actually see the idea of why it's called the vertical line test. Is number 1 a function? Yes, function. Okay, let's go to number 3. Let's talk about number 3 for right now. Okay, now listen, 3 and 4 is going to confuse some of you a little bit, but not difficult. The function, not a function, you can get. Is number 3 a function? Yes. Is number 4 a function? No. Because when x is -6, you get a bunch of different y coordinates, right? So not a function. All right. For number 3, let's talk about the domain for number 3. Domain is you go along the x-axis, right? Can you kind of tell me what you think the domain is? Negative infinity to infinity. Because I'm going along the x-axis. So you see these arrows pointing to the left and right? So negative infinity to infinity. Okay, so that's good for that one. All right, now here's what's probably going to get you. What do you think the range is? Remember, the range is a set of y coordinates. It is just what? 5. That's it, right? Do y'all see that the set of y coordinates are all the same? It is what? 5. Now here's how you're going to write it. Is 5 a finite or infinite set? So use that set notation. So you say range equals set with just 5 in it, like this. See how to write it? Number 4, what do you think the domain is in number 4? What'd y'all say? -6 only, right? Because remember, the domain is a set of x coordinates. Well, look at this. What are all these x coordinates? Now, she said bracket. You said brace.
Oh, well, yeah, the bracket.
The brace. -6. But what is the range? Yeah, because the vertical line goes up and down like this. So you're going from negative infinity all the way to what? Positive infinity. Okay? All right, now let's go to the one with the finite set. Okay, number 9. First of all, let's talk about, is this a function or not? So is number 9 a function? Yeah, because look, when x is -6, there's only one y value. It's what, 5? When x is -4, there's only one y value. It's what, 2? When x is -2, there's only one y value. And so on. Same thing here. When x is 2, -2. When x is 4, -2. When x is 6, -2. So is this a function? Yes. Let's go to number 10 and determine if that's a function. Is number 10 a function? No. Where in number 10 is the issue? -2. Very good. When x is -2, see, it kind of fails the vertical line test right here. Because my vertical line crosses the graph how many times here? Twice. When x is -2, my y values are -2 and what? -5. So very good. So this is not a function, since when x equals negative 2, there are how many y values? 2 y values. And my y values, if you want to go further with it, the y values which are negative 2 and negative 5. Okay? So that's not a function because of this little part right here. The dots that are right under each other. The points that are right under each other. Okay, now let's talk about domain and range. Is this an infinite or a finite set? Finite. So just like with the set of ordered pairs, you do the finite set with those braces and you just list your x coordinates. You just list your y coordinates. And if it occurs more than once, you list it once. So let's talk about the domain here. And just go from left to right. What is this x coordinate right here? Negative 7. Don't forget to do the brace. Now go to the next x coordinate. What's the next x coordinate? Help each other. Negative 4. Good. What's the next x coordinate? Negative, not negative 3. Negative 2, right?
That's supposed to be a negative 6 for the first one.
Yep, you're right. Thank you. Yeah, negative 6. No, you're right. Negative 6. Negative 4. Negative 2. What's the next one? 2. What's the next one? 4. What's the next one? What's the next one? And that's it, right? So that's your domain. Okay? See, that's a finite set. I can count how many points there are on this relation. So use that brace. What's the range? So remember the range, you're going to look at your y coordinates. And let's just go from left to right. It doesn't, or you can go from bottom up. It doesn't matter. It's only the interval, guys. It's only the interval where you got to go from smallest to largest. If it's a finite set, it doesn't matter what order you have all these y coordinates in. But let's just go from bottom up. What's the smallest y coordinate? Negative 2. It occurs quite a bit, but you only list how many times? Once. What's the next y coordinate? Positive 2. Very good. What's the next y coordinate? Very good. Next one? And that's it. Okay? Number 10. Let's talk about the domain. Let's go from left to right. What's this x coordinate right here? Negative 7. What's this x coordinate right here? Negative 5. What's this x coordinate right here? It occurs twice, but I only use it how many times? Once. What's the next x coordinate? Good. What's the next x coordinate? And that's it. Good. Range. Let's start from bottom up. So negative 5. Negative 2. Positive 3 occurs how many times? Only use it once. Next one. Yep. And last one. Yep. And that's it. Okay. Interval rotation. Finite set notation. All right, let's look at number 11. Is number 11 a function? No. Is number 12 a function? No. So both of them failed the vertical line test. So not a function. Not a function. Okay. Now, let's talk about domain and range. Okay, so let's do domain for number 11. First of all, is this going to be interval notation or is it going to be a finite set? Interval. So domain, you go along the x-axis. So I'm going along the x-axis. I'm asking you this. Is this where I start touching the graph? No. I start touching the graph when x is what? Negative 5. Bracket negative 5 all the way to what? Infinity. Because these arrows imply keep on going. With parentheses. So there's your domain. Now the range. Very good. Because remember, this kind of says it keeps on going like this, right? Same thing here. So I'm asking you this. if I consider this down here, negative infinity, am I going to get a point in the graph? Yes. So I'm going from negative infinity all the way to what? Positive infinity. So that means that any real number is going to be a coordinate for y. Number 12. What do you think the domain is for number 12?
Parentheses, negative infinity, positive or, and then the square, what is it called?
The bracket?
Yeah, the bracket.
With what number?
4, positive 4.
4. Okay, so you're going to go from along the x-axis. So you see these arrows keep on going like this. So you go from negative infinity all the way, and I'll stop when x is what? 4. I'll stop when x is 4. What about the range? I'm sorry. Yeah, I'm sorry, guys. That's domain, right? What about the range?
Negative infinity, positive infinity.
Y'all agree? Okay. All right. So negative infinity to positive infinity is the range. Okay? All right. It helps if you use something like this and going along the x-axis or going along the y-axis. It does help. It also helps if you know right away whether there's going to be an infinite set or a finite set, just like these were. Also, be careful when it's a horizontal or vertical line, because in both of those, one's an interval, the other one is a number. It's just one element in both of these. Okay. All right. So let's see what I can do right now in terms of worksheets.